In this one, they give you a data set and they ask you for the regression line, and it's basically the same as what we did in section 10.1, where you open the data set in StatCrunch. You see the X and Y columns, and then you do stat, regression, simple linear. The X variable is X, the Y variable is Y, and that's all you have to do in that menu. And then you hit compute, that's at the bottom of the screen. And the regression equation is up here at the top. So in StatCrunch it just says Y, but it really should be Y hat. And then this says round to 2 decimal places, so you have 3.6 for the constant and 1.1 for the coefficient of X. So it's like 3.60 and 1.10, but you don't have to write the zeros. For the scatter plot, you just arrow the output, and that gives you the scatter plot. So it looks like this one where it's concave down. And then I think that's the last question. Identify a characteristic that is ignored by the regression line, and that's that it's curved. So there is a pattern, but it's not a straight line pattern. This question is similar, where they give you a data set and ask you for a regression equation. So you open it in StatCrunch and do stat, regression simple linear. The X is the chest size and the Y is the weight. And then you hit compute. And the constant is negative 229.64. Round to 1 decimal place, so just 0.6. And then the slope is 10.2. And then they ask for the best predicted weight. If you look at this, the p-value is small, and so we should use the regression equation. This is at the 0.05 level, so 0.0018 is smaller than 0.05, and so we would use the equation to get the best predicted weight. If the p-value was bigger than 0.05, then you would use the mean of the weights, the average of the weights. So in this case, you would just plug 43 in for X, and that'll give you the answer. Another way of doing it, like you could just do it on your calculator, or you could do it on StatCrunch, where you put in 43, where it says prediction of Y, put in 43 for X. And at the bottom, now you have a new table, and the predicted Y is 207.1. But we were only able to do that because the p-value over here, the p-value for the slope, was really small. It was less than 0.05. That's why we were allowed to plug the 43 into the regression equation to get the predicted weight for a bear. This is a different question that is similar in that, they give you the data and they want you to write the regression equation. So I did it in StatCrunch and copied it down. And then it says, given that the systolic blood pressure in the right arm is 95, find the best predicted systolic blood pressure in the left arm. But again, remember, you have to look at the p-value first, and over here the significance level is 0.05, the p-value is 0.0644. So the p-value is bigger than the significance level, which means we can't use this equation. It's a bad equation. So to make a prediction, don't use the equation. Don't plug 95 into the equation. Instead, what you need is the mean of the systolic blood pressures in the left arm. And the way to do that is you could just do stat, summary stat column, and select left arm, and we just need the mean. And the mean is 163. So that's how you do it if you have a bad p-value, if you have a big p-value.